Hello and welcome to the world of subnetting. So we have two examples. We're going to do some subnetting and we're going to master subnetting, and you need to master subnetting in effect. So you need actually to calculate in your head. They're going to give you a paper and pen in the CCNA exam, and you need to be fast to do the subnetting to answer some questions that are going to be in the CCNA exam. So we have two questions, as you can see. We have two formulas that we need to remember on the top of our head. So the first formula, it's for the number of networks. So if we are interested of number of networks, then the formula, okay, it's 2 to the power of n. So number of networks equals 2 to the power of n. The n is the bits borrowed from the host field. The IP address is always, okay, two portions. For example, I'm gonna, let's say 192 here, say 192.168.1.0/26, okay? So /26 subnet mask tells me that, okay, 26 bits are for the network portion and the last bits are for the host portion. So here we have 8 bits plus 816 plus 824. So the bit number 26, it's reside on the last octet. That's why I'm going to write the last octet in binary. Okay, so we have 8 bits here. Then I'm going to count, okay, bit number 24 in the third octet, then 25, 26, and then I'm going to draw a vertical bar right here. All those 26 bits are for the network portion, and the remaining 6 bits are for the host portion. If I would know, or I want to know actually how many hosts are in this network using the /26 subnet, then we are going to use this formula. The number of hosts equal to the power of h minus 2. H is the number of host bits. The number of host bits are 6, as you can see. So 2 to the power of 6 minus 2 equals 62. So using /26 mask, we are going to get 62 hosts or usable hosts per network. Okay, so let me clear my gibberish, or let's actually bring the notepad ++, and we are going to work on those two examples, as you can see right here. So let's actually work on the first example. So in the first example, we have 192, as you can see right there. Let me write the IP in Notepad++. So in the first example, okay. So the first example says, okay, divide the network 192.168.1.0/24 into 4 networks. So we're looking for networks. How we are going to do this? So we can actually figure that out using this formula right here. So we know the number of networks. So we are looking for the number n. How many bits we need to borrow in order to get at least 4 networks. Here is how we can do that. So let me grab my pen here. Okay. And then let's actually write down the formula. Sorry. So 2 to the power of n should be greater than or equal to 4. So what will be the n? Okay. So how many bits we need to borrow in order to get at least 4 networks? Is it 1? So if we borrow 1 bit, 1 to the power of 1 is 2, and 2 is not greater than or equal to 4. Then 2, so 2 to the power of 2 is 4, and 4 is greater than or equal to 4. So 4 is equal to 4, then we need to borrow 2 bits. Let's actually bring the Notepad++ back, and let's actually do this right now. So yeah, so I'm going to write the IP address. So 192.168.1.0. So the /24, it's right here in the third octet. Then I'm going to write the host bits. So the host bits are 8 bits. So I'm going to write 0 from decimal to binary. Okay, I'm going to write it like this. I'm going to include some space because I need to use the power of 2 on the top. So I'm going to use the power of 2 on the top of those bits right here. Let me do it like this, or let's do it like this. Okay, so this bit here, bit position, so bit position number 128, 64, 32, and 16, 8, 4, 2, and 1. And let's align those bits here with the base of 2. So this is 16, this is 8, 4, 2, and we need, I think, another 0 here, right? So yeah, 8 bits right there. 4 is 8 bits. So yeah, okay, so we're good. Now we're looking for, as I mentioned here, to the power of, yeah, we find out the number of bits that we need to borrow. Then I'm going to count. We have 24 bits here, so I'm going to count 1, 25, 26, and then I'm going to draw a vertical bar right here. Okay, this will give me the first network. Okay, and what I'm going to do right now, I'm going to copy all those bits here. I'm going to copy, and then I'm going to paste right here. So I'm going to paste those bits and write in what. So yeah, I'm going to copy those bits here. So let's copy them. I think I didn't copy them. So yeah, I'm going to copy those bits right here 3 times. So 1 for the network, the second for the first IP. By incrementing the last bit after the vertical bar, the last bit after the vertical bar, okay, we will get the first IP right here. Copy once more. This, we need to increment all the bits except last one after the vertical bar to get the last usable host or last IP address, last IP. And then I'm going to copy once more for the broadcast address, and then increment all the bits after the vertical bar. You will get the broadcast address. Okay, so the broadcast. Now, so we find out the first host, we found out the first network, the first host, last host, and the broadcast. So let's write them down right here. So LAN, let's say LAN 1. It's 192, the network address, 192.1.0. And the first host, I'm going to write just the last octet because everything remains the same. So the first host, actually, or the first usable IP address is actually .1, as you can see. So 128, there is no 128, no 64. So there is only the 1 right here. I'm going to make it in line with... I think I might have, yeah, it's yeah, something like that. The age should be okay. Let's move back. Yeah, exactly. So it's .1, and then the last host, as you can see here. So 32 plus 16 plus 8 plus 4 plus 2. It will give me the number 60.62. Okay. And then, of course, the broadcast is the number that comes after the last usable address, which is 63. And next network that we're going to use for LAN 2 should be 192.168.1.64. Okay, should be 60.64. So I can write the 64 here, down here. Okay, like this. In the exam, you can do this. If you get confused and you don't know how to actually figure out the first, last, and the broadcast, you could do it right here. Or I can just manipulate I can write the 64 bits right here. So 64 by incrementing this bit right here. So I'm writing 64 in binary, and then I'm going to copy 3 times, and then incrementing the last bit will give us the first IP. Incrementing all after the vertical bar except last one will get last IP. Incrementing all the bits after the vertical bar will get the broadcast. So what will be the broadcast? What will be the first host will be 65, and then the last host will be dot actually yeah. So the number of hosts that we're going to get, it's 62 per network. So this will be 126, okay? And then dot 127 is the broadcast, and next usable or next actually network that we're going to use is 192.168.1.128. Notice, if you watch the video, the previous video for the subnetting, the introduction to subnetting, we can use the magic number. So using the magic number tells us that if the magic number tells us actually that if the first network starts with 0, then we are going to increment the second with the 64, the third by adding 64 and 64. So we can do that. So LAN 3 right here is 192.168.1. Plus 64 is 192. Correct. And then we answer our questions. So the IP after 128, so the first usable IP address in LAN number 3, so LAN 3 here, and then LAN 4 right here. Okay, so 129 is the first IP, and the last IP. Let's actually figure out the broadcast. It's easy to figure out the broadcast here. So the broadcast comes before the next available network, as you can see. So it's 191, and before 191 we have 190, and right here in the last we are going to start with the 193. So it's number after the okay, and then it will go all the way to 254, and .255 is the broadcast in the last network. Then we answer our questions. We get 4 networks, as you can see, LAN 1 to LAN 4, with actually the first usable host and the last usable host and broadcast on each LAN or each network. And then that's the IP design for the first example. So let's move to the second example. Second example is a little bit difficult because it's using /22. So let's actually step up out of our comfort zone. So here is the IP address. I'm going to write it down, 172.25.240.0, and it's /22. So /22. Okay, so the question says divide the network 172.25.240.0 /22 into 4 networks. So we're looking for actually 4 networks. Then we are going to use the same. So to the power of 2 equals 4, and 4 is greater than or equal to 4. So the bits that we need to borrow are actually 2. But in case we have /22, so /22 is on the third octet, because here we have 8 bits plus 8, 16. Okay, and then we have 17. We have 8 bits here from 17 all the way to 24. So 22 must be on the third, okay, octet. That's why we need to write both octets, the third one and the last one. So I'm going to write the 240. Let's go right here. I'm going to write 240 in binary. So 240 in binary. Let me write on the top of the base of 2 on the top. So 32, 16, 8, 4, 2, 1 right there. And then I'm gonna write the 242. So I'm gonna write the dot, and then 242. So is there 128? Yes, the answer is yes. Is there 64? The answer is yes. Is there 32? The answer is yes. Let me write it here. So 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, exactly 240, and then the rest are all zeros. Okay, if you get confused, you could also do the other method. So what we can do here, let me show you how we can do this. And let's actually delete the, let me delete this gibberish from here. There we go. And let's actually figure out how to use the how to convert 240 into binary. So to convert 240 in binary, what we can do, can actually write the base of 2 on the top. So let's write the base of the 2 on the top. So 1 to the power of 0, 2, 4, 8, 16, 32, 64, 128. Then we have 240 that we need to actually convert from decimal to binary. So how many 128 inside of 240? It's 1, and then subtract 128 from 240. Okay, so 240 minus 128, it's actually 240 minus 128. So it's 90, yeah, it's like 130, so 110, 108, I think. Okay, 108. Then ask how many 64 inside the 108. It's 1, and then subtract 64 from 128. We will get actually, so 108 minus 64. So 8 minus 4 is 4. And then 10 minus 6 is actually 4. And then here we have, okay, so 44. So how many 32 inside 44? It's 1. And then let's subtract 32 from 44. So 44 minus 32. This will actually give us 12. So yeah, sorry, I think I made a mistake. I think it's yeah, let's say 130 minus 240, it's 110, correct? 110, and it's 112. It's 112 here. Yeah, 112. So 112 minus 64. 112 minus 64 is actually 48. Okay, 48. 48 minus 32 is 16, exactly 16. That's why how many 16 sides of 16? We are going to get 1. Subtract 16 from 16 is 0. And then the rest are all going to be zeros right here. And that's the binary number of 240 if you get confused. So you could do it, okay, like this. Let's go back to our example. So yeah. So this is the first octet, and then I'm going to write the second octet. So I'm writing the 240 and the 0 as well. So 0 is actually 8 zeros right here. Okay, so 0, 0, 0 right here. And then I can write again I can copy the base of 2 and then paste it right here on the top. Okay, can just paste it on the top right here. Let's make those bits in line with okay, so we are good. Okay, we are good. Now the question is, we need 4 networks, okay, right here. So we need 4 networks. So how many bits we need to borrow? Let's actually look for the original mask. So the original mask is /22. So here we have 16 bits right here. So 17, 18, 19, 20, 21, 22. And then I'm going to draw a vertical bar right here, okay? Just temporary vertical bar. This is the original mask. I'm going to need to borrow 2 bits, so 1, 2, and then I'm going to draw another vertical bar right here. I'm going to delete the old one. That will be the new subnets mask. So new subnets mask here, the new mask will be /24. Okay, /24 means that the subnets mask, all the bits are turned on, the 24 bits turned on. It's actually in decimal 255.255.255.0. Okay, go back to the numbering system if you don't know how to write, or you need to remember the charts, by the way. Okay, /24 the mask, /26 the mask in decimal, /28 and so on. So you need to remember the chart on the top of your head. When you enter the exam, you could write the chart. The first thing to write is the formulas and the chart on the paper. So yeah, /24, and then what I'm going to do right now, I'm going to copy all those bits here and copy 3 times as we did, okay, all the time in step 2. So let's actually copy, okay, this, we increment the last bit after the vertical bar, and then copy once more. We increment all the bits except the last one. So I'm going to increment all the bits here. So after the vertical bar, remember, after the vertical bar, okay? So don't get confused. And then this one will be the first net, okay? The LAN number 1. And then this will be the first IP. This will be the last IP. And then copy once more here. Incrementing all the bits after the vertical bar, we will get actually the broadcast. Okay, so we'll get the broadcast right here. And then this is the broadcast. So now we can actually figure out the first host, last host, and the broadcast. So LAN 1 or network 1 equals, okay, 172.25.240.0. Okay, the first usable IP, as you can see right here, it's right here, so it's .240 remains the same, .0. So 240.1, sorry, 240.240.0. Always write both the third and the fourth octet, okay? .1. And the last actually usable IP address, so we have 240, and we have all those bits turned on, so 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2. What you could do, you could subtract 1 from the subtract 1 from 255, then you will get 254. So it's 240.240.254. And for the broadcast is 240.255. Okay? Net number 2. So for net number 2, using the magic number, as you can see here, the magic number tells us it's 1. So always the increment, our increment will go with 1. And notice the 1 is at the third octet. Is not at the fourth octet, is at the third octet. So we are going to increment 240 with 1. So 172.25.241 right here. And then actually, yeah, 241.0, right? Right here. Because our increment always will go with 1. So I can write 241 right here by incrementing the bit, okay? The bit position number 0. I mean, this bit position here. Can increment it, and then I can figure out, okay, what will be. You could write, if you actually get confused doing this, you could actually write 241.0 right here, and then copy 3 times and increment last bit, increment all except last, increment everything. You will get the first host, last host, and the broadcast. So this will be 240. Let's actually, yeah, see this. So 240 for the first usable IP, it's 241.1. And then the last usable IP, it's 241.254. And then 241.255. And then next network, the third net will be 172.25.240. 240. Actually, our increment will actually, yeah, since we are here, we'll always go with 1. So 242, exactly. So yeah, 242.0, and then you get the idea. So 242.1, and then .242.254, and the broadcast will be 242.255. And the last network number 4, we are going to get, let me move my window a little bit. So it's 243 here, right? 243.0. And then you can actually, if you get confused, you could actually use the, you write in binary, you copy the bits, so to actually get this, okay? So yeah, 243.0, 243.1, and then 243.254 and 243.255 is the last, network. So we answer our questions. We get 4 networks, as you can see. And in each network, how many hosts we can get in each network? We have 8 bits in the host field. Using this formula here, we will get 2 to the power of 8 minus 2 is 254, IPs per network. And as you can see here, the first one starts with 40.1 to 240.254, 241.1 to 241.254. As you can see, we get 254 hosts per network. I hope this has been informative for you, and I would like to thank you for viewing.